Hello, good afternoon everyone, and today we're going to learn the circles theorem. There are 7 theorems and we are going to go through each and every one of them. The first theorem is angle in a semicircle add up to 90 degrees. The second theorem is tangent to the center of the circle is also equal to 90 degrees. The third theorem is angle at the center of the circle is 2 times the angle at the circumference. Fourth one, angle on the same arc are equal. Fifth one, we have learned in the triangle theorem, base angle, isosceles triangle are equal. The sixth and seventh is more for year 11. Opposite angle of cyclic court, they add up to 180. And for the last one, exterior angle of cyclic court is equal to the interior opposite angle. And we shall look at each and every one of them. The first theorem is when you have a circle, and if you have a line that cuts across the middle, the center O, that means you have 2 semicircles. If you were to draw a point on the circumference, that angle will always be 90 degrees. So the first theorem is that angle on a semicircle, they must add up to 90 degrees. We shall look at an example now, okay? So in the exam, you have a question that is 40 degrees, and you need to find angle X. So how you do that? Okay, first you need to know, we label them as A, B, and C. So angle A, B, C, which is this angle here, have to be 90 degrees. Why is that so? Because the theorem states that this is a semicircle and any point on the circumference, so angle on a semicircle, they must add up to 90 degrees. So first we need to know that that is 90 degrees. To calculate angle X is simple now, because you know the sum of the interior angle of a triangle add up to 180. So angle X has to be 180 minus 90 minus 40, and the answer is 50. And you must give me the reason sum of the interior angle of a triangle add up to 180 degrees. Now we look at the second theorem. Second theorem is about a tangent. What is a tangent? A tangent is a line that cuts through the circle at only one point. So the tangent, so that is called a tangent. So the next theorem is that tangent to center of circle, they must add up to 90 degrees. So center is O, so you need to know that that is 90 degrees to the center of the circle. So we look at an example now. If you have the same example with numbers now, okay, that's the tangent, that's the circle, and that is 37 degrees. You want to find X. So we label that O, A, and B. So we need to know that angle OAB, this angle here, okay, have to be 90 degrees because the theorem states that tangent to center of circle, they add up to 90 degrees. If this is 90 and that is 37, X is simple. Angle X will be 180 degrees minus 37 minus 90, and the answer is 53. And again, you must give me the reason, because the sum of the interior angle of a triangle, any triangle, they must add up to 180. So this X, 37 and 90 must add up to 180, and X will be 180 minus 90 minus 37, and that is how you calculate the second theorem. We'll proceed. The next theorem we have is another theorem which is based on the angle center of the circle. It is, so this is center O. If you draw a line across to the circumference, so that angle X and angle Y, X will be double that of y. So for example, if we know that y is 40 degrees, so if you want to find angle x will be double that of the angle 40 degrees, so angle x will be 80 degrees, double. So the reason is that angle at center equal to twice angle at circumference of the circle. That is how you calculate the third theorem. Angle at center is 2 times the angle at the circumference. Okay, the fourth theorem is quite easy. It looks like a form of a butterfly. If you have a circle and you have 2 points here, okay, and all the points must touch the circumference, the angle at the top, they are the same, and the angle at the bottom, they are the same to each other. So angle A and angle B. So angle A is equal to angle B, and the bottom C and D. Angle C is also equal to angle D, and the theorem states that angle on the same arc, they are equal to each other. Very straightforward. Okay, the next theorem for the year 10 is going to be quite similar to what you have learned in triangle. So if you have a circle and you have the center of circle O, and you want to know, first you need to know that these two sides are the same. Why? Because they are the radius of the circle. If that two sides are the same, that becomes an isosceles triangle. In that case, this angle and that angle have to be the same. So the theorem is called base angle isosceles triangle are equal. Straightforward. Okay, now for the year 11 guys, okay, we are going to introduce something called cyclic court. A cyclic court is a circle and you have a quadrilateral inside a circle. The first theorem states that these two angles, the one opposite each other, angle A and angle B, angle A plus angle B, they must add up to 180 degrees. So the theorem states that opposite angle cyclic court equals to 180. This is a quadrilateral inside a circle. It's called a cyclic court. So the one opposite each other, they add up to 180. Similarly, C and D will also add up to 180. And the last theorem for cyclic court is this. So if I have an exterior angle, maybe X, angle X, the exterior angle of cyclic court is going to be the same as the one opposite it. So angle X is equal to angle B. The theorem is exterior angle of cyclic court is equal to the interior opposite angle. So in other words, if I were to do another exterior angle, suppose this is Y, and Y is the exterior angle, and they are the same as the one opposite it. So Y, angle Y is equal to angle C. Yes, the circle theorem is a bit complex, but if you understand the seventh theorem, you should be fine. So I repeat again, the seventh theorem you need to go through, again, based on what I've written below. Angle in a semicircle, they add up to 90. Tangent to the center of the circle is 90. Angle at center is twice the angle at circumference. Angle on the same arc are the same. Base angle isosceles triangle are equal. Opposite angle of cyclic court, they add up to 180. And the last one that we go to quickly was that exterior angle of cyclic court equal to the interior opposite angle. Thank you and have a good day and enjoy learning.